My name is Vicky and this is my video lab report, Lab 2, Gravity and Drag Force. So the purpose of this lab is to compare an observed application of Newton's second law that includes gravitational force and drag force to a VPython model. The physics principles used in this lab are Newton's second law, which is the final velocity is equal to the initial velocity plus the net force over mass times delta t, the gravitational force, which is negative mg, g being 9.8, the gravitational constant on Earth, drag force, which is negative v squared times b, and the net force is calculated by adding gravitational force and drag force. So the main changes in the code are my mass, time, obviously the same gravitational constant, j hat, b, calculating the net force, predicting future motion, and predicting future position, as I will show here. My mass of my frisbee in this is 0.175 kilograms, and the gravitational constant is 9.8. My j hat vector is 0, 1, 0. My b is 0.018, which is obtained by finding final points in Tracker and changing my code until the result was the same as my Tracker one. In this part, I'm calculating the net force. The gravitational force is negative mg times j hat. My drag force is negative b times v squared. And my net force is the addition of these two forces. I'm predicting new velocity in this part of my code, and I'm predicting the new position in this part of my code. So this is my video of a frisbee being dropped. In the graphic comparison, the red line is Model 1 with just gravity, the blue line is Model 2 with drag, and the purple is my data obtained from Tracker. So obviously this is a little bit more off from my model, and here's some reasons why. The object that I use, which is a frisbee, has a lot of surface area, which could have thrown off the data, and also it might be a little squiggly looking because I might not have been precise in obtaining points from my Tracker video. So what does it mean? So which model or models predict a terminal velocity? And this would be the modified computational model with drag force, because it includes terminal velocity, which is the sum of the drag force, when the sum of the drag force is equal to the downward force of gravity. So what if, would the terminal velocity, if the object was initially thrown downward, be the same or different from the case where the same object was initially dropped from rest? And the terminal velocity would not change, only the distance traveled would change. And I would show that. So this graph is showing a parabolic shape, and if my time were to continue, this line would eventually flatten out to vertically, which would show terminal velocity. So even if this initial throw was put down, the terminal velocity would still be the same. In conclusion, Newton's second law can predict motion accurately when drag force is added to the gravitational force, as shown here. Thank you very much.